Good day, everyone. Our topic for this afternoon is about the integration of hyperbolic functions. So, for integration of hyperbolic functions, our objective is to identify the different hyperbolic functions, find the integral of given hyperbolic functions, determine the difference between integrals of hyperbolic functions, and evaluate integrals involving hyperbolic functions. So, here are some definitions that you have to remember in hyperbolic functions. So you can pause this video and copy everything first. Okay, so for the next slide is the differentiation formulas. If you can remember in your differential calculus, here are the things that you have remembered, right, in hyperbolic functions integration. However, note that hyperbolic functions are defined in terms of exponential functions. So if its differentials may also be found by differentiating its equivalent exponential form. Similarly, the integrals of the hyperbolic functions can be derived by integrating the exponential form equivalent. So we will know more about that later on our examples. Now again, these are the integration formulas that you have to remember all the time. So you can pause this video and copy everything. So for number one, that's sine HU du, that's cos u plus c, or the hyperbolic cosine plus c. For cosine hyperbolic, the integral of the hyperbolic cosine of u du, it's hyperbolic sine of u plus c. So notice that it's almost similar with the normal integration formulas. However, you can see that everything in sine and cosine is positive, right? Whereas the integral of the cosine, right, or the integral of yes, sine is negative cosine, but here everything is positive. So let's proceed. And again, I hope that you will remember all those integration formulas. You will memorize that one since on exam you will be having these types of problems. So for hyperbolic functions versus trigonometric functions, there is somehow a bit difference with the two. So here you can see that it's minus, but here it's plus, right? So that's the huge difference. Also here and also here. All right. So kanilang siya inyong need i-remember afterwards. If you remember the hyperbolic cosine of x minus hyperbolic sine or sine h, x squared minus 1 equals 0. So if you can remember this identity, you just need to divide all of them with sine and cos. So for example, if you divide all of them with cos rather, so that's 1 minus tan, sine over cos is tan, right? Tan h squared x is equal to 1 over cos is secant. So there you go, we derive this formula. Now if you are going to divide that with sine, so cos over sine, that's cot h. Sine over sine is 1, and 1 over sine h is cosecant h squared x. Also, you need to remember these formulas or identities here given. So once again, you can pause this and please copy. Because again, you will be needing to simplify or look for some solutions in order for you to integrate the following examples. Okay, so here are some double angle formulas, the same. Okay, so remember these ones again. You can copy these identities so that we can answer the following examples later on. Alright, let's proceed with the examples. For number one, evaluate the following integrals. Sine h of 1 minus 3x. So let's answer number one. right. So for number 1, uh, we can actually let u as 1 minus 3x dx. Sorry, 1 minus 3x rather. So du here is negative 3 dx. Our dx is d over negative 3. Okay, so dx equals negative du. So many. Hold on, sorry, I think okay naman yung type here. Du over 3. So therefore, if you can rewrite this equation, that is sine h of u negative du over 3. So that's actually negative 1/3 integral of sine h u du. So therefore, that's negative 1/3 cos. What's u? It's 1 minus 3x plus c. And that is your final answer. Okay, very easy number 1. How about for problem number 2? So for problem number 2, let me erase this one first. Cos x over 2 plus sine h 3x. Diba, remember that the integral of sine h x is positive cos x. So therefore, we can let the denominator as our u here. Okay, so u is equal to 2 plus 3 sine h x. Du equals 3 cos x times 1, right? So, sorry, I forgot the x. Oh, I forgot the x here. Ah, this should be cos x. Okay, so yeah, there we have cos x dx here. So we just need to divide both by 3. So that if you rewrite number 2, that's cos x dx is again du over 3. And 2 plus sine h3x is your u. So therefore, that's 1/3 du over u, or that's 1/3 ln of, what's your u? That's 2 plus 3 sine hx plus c, and that is our final answer. Okay, for number 3, number 3 is that we are going to prove that sine hx dx is just equivalent to cos, or the hyperbolic cosine of x. So remember the identity that sine hx dx is katong giingon kaganina, we have heard, or we have discussed it earlier, that the integrals involving hyperbolic functions were actually derived from exponential functions. So therefore, we are going to convert number 3 as exponential function. So that's sine hx is equivalent to e raised to x minus e raised to negative x all over 2. Pag cosine po yan siya, or hyperbolic cosine, that's actually plus. Okay? So this is plus pag cosine. Since it's x, it's minus. So how are you going to integrate that one? Simple, very simple. We are going to bring out the constant. Then that's e negative of ex minus e negative x dx. Close parenthesis muna natin kaya para when we distribute, we will not forget 1/2. So here it's 1/2, and then integral of ex dx minus 1/2 integral of e negative x dx. Remember in our previous lesson, ex dx is just equivalent to ex, right? So therefore, this is 1/2 ex minus, so let u as negative x. Du is negative dx. Sorry. So therefore, this is e. So negative du is positive dx. e u, we are going to convert this one in terms of u. Then negative du. Okay, then ano siya plus c, right? So that's 1/2 e raised to x. So plus, okay, negative and negative here, that's plus 1/2 eu du. So eu du is eu plus c. So e raised to negative x plus c. Okay, so we can simplify that one. So that's 2, then ex plus e negative x plus c. Or that is just cos x plus c. Okay? Alright. Alright, now for number 3, for number 4 rather, we have cos x. This one is so easy. Diba? Remember that cos squared x minus 1 is just equivalent to sine h squared x. So, for number 4, let's answer that. Cos x over cos squared x minus 1. So again, that is just equivalent to cos x over sine h squared x. Okay, that's equivalent to, if we separate that, cos x over sine h x times 1 over sine h x dx. Why do we forget dx? Sorry. Okay, so that's cos over sine, it's cos over sine, it's cot, right? I forgot. Yes, cot. Because sine over cos is tan. So this is cot h x times 1 over sine, it's cosecant h. Sorry. Cosecant h dx. So remember that this is actually one of the what do you call this, integration formulas. That's number 6. So according to number 6, cosecant hu cot hu du is equivalent to negative cosecant hu plus c. Therefore, this is negative cosecant hu plus c. So that is negative cosecant h x plus c. And that is our final answer. Okay, for number 5, this number 5 seems kind of different because we have combined exponential and hyperbolic function. Actually, uh, if you can see problems like this, one thing that actually automatically pops up in my head is that I will easily or automatically convert sine hx into exponential form as well, since they are not interrelated and we cannot do anything about that one. So therefore, that's ex minus e raised to negative x all over 2 dx. Right. So therefore, that's you can actually combine them and we can actually combine them afterwards. So this is e raised to 3x minus e 2x minus x, it's raised to x, right? All over 2 dx. Okay, so is that correct? Yes, that's correct. So that's is equal to, so that's 1/2 integral of e3x minus e x negative ay x lang dx. So sorry. Okay. So therefore, we can separate them at 1 half integral of e3x dx minus 1 half ex dx. So therefore, that's automatically this one, we should change it as u du muna, no? U equals 3x, du is 3 dx, so du over 3 is dx. So therefore, this is 1 half eu du over 3 minus 1 half ex, no? Plus c. So what will happen here is that 1 half or 1/6 rather, then eu is 3x diretso minus 1 half ex plus c. Okay? Or we can easily substitute that or simplify that into 6 e3x minus 3ex plus c. That can be your final answer. All right, and the last one, number 6. For number 6, that's okay. So actually, we cannot let the denominator as our u. So guys, if you can see problems like this, walay exponential sa taas pero nasa baba, we can actually add some, no? If we dili lang nato, we will not violate the rules in algebra. By multiplying ex over ex, that's just equivalent to 1, so it's not illegal. Therefore, we can have simplifying that as 2ex all over. This one is, ah, sorry, e raised to 2x plus 9 negative x plus x raised to 0, or that's equivalent to 1. Tama? Okay? So therefore, this is just equivalent to 2ex dx all over e2x plus 9. Okay? So now, is there something that we can do here? So there is, right? Actually, this is a mix of um, hyperbolic and inverse trigonometric integrals. So nakita natin that this is like tan, the inverse tan, right? This because, okay, I will show you how. Because that's u is equal to e x. If u squared, e 2x, right? So therefore, our du is ex dx. So therefore, if we rewrite that, that's 2 ex dx is du all over u squared plus 3 squared. Okay? All right. So do you remember that arctan is 1 over a, then arctan u over a plus c. So that looks like this one, right? So therefore, this is 2 times 1 over, what's your a? That's 3. Arc tan u, it's still u, all over 3 plus c. So if you're going to simplify that one, that's 2/3 arc tan e raised to x over 3 plus c. And that will now be our final answer. Okay, so guys, if you have any questions, please do not hesitate to contact me on LMS or on my email. And if it's on emergency, my mobile number is attached to our module. So thank you guys for listening. Have a very great day.